Video?
Yeah. Let's see. Live stream, yeah.
Okay, okay. I
What
just
does it
see.
say?
Got it?
Yeah.
If anyone likes to see.
Got it.
Got it, got it.
Yeah.
Okay, good, got it, okay.
Chris, are we good?
Yes, I'm descending into the man.
We are
cave.
good, thanks.
Okay.
Hello, Matthew.
Hi, how's it going? How's it going?
It's going very well, thank you. We've got a good crowd showing up here tonight. Where are we at? We're at 35. Wow, keep them coming. Okay.
Okay, just so everybody knows, we are now streaming live to YouTube. And as you heard, the meeting is now being recorded as well.
Awesome. Okay, hello, everybody. Thank you for showing up on this mid-January evening, probably the one time in the month and a half that we've got a clear sky, of course, and it's meeting night.
Yeah,
That's
always.
normal. That's the bane of astronomers. It's either meetings or clouds. Anyway, just a couple of announcements. Well, first of all, we have a bunch of new people here with us tonight. Welcome. I was going to say, usually at this point I say wave or whatever when you, if you're new here, but I wouldn't be able to catch it all anyway. But I bid you welcome. I'm Bernie. Vanessa is my last name. I'm the chairman of this group. This is my second time round as chairman. I'm quite honored to do this, even though I secretly and sometimes silently mutter under my breath, and you all have heard me, but it's well worth it when it comes out at the end. This club's been around for better than 20 years, I'll say, just to be safe. I know it's better than 25. We have a couple of nice little features in this club. For those of you who don't or are not all that familiar with us yet, one of these things is we have a telescope loaner program. And perhaps I should get Melissa to speak to us about that just a little bit.
Hey folks, so yep, like Bernie said, it's one of the perks of being in the club. There are many, but this is a good one. We have scopes for that you can loan and equipment. And if you go to the website and off the top of my head, you'll find it. You navigate around the site, and I've got a list there of the different scopes that we have, and if they're available or not. If you're interested, though, don't take the yes available, not available to heart, because sometimes I forget to get Chris to update that. So if there's a scope that you're interested in, let me know. If you come and pick one up, you have it for a month, and which is nice, especially in the winter, because sometimes there's, like Bernie was just saying, you know, you have it for a month and maybe there's 5 good viewing days. At the end of that month, if no one else has requested it and you want to keep it again, you can hang on to it for longer. And there's different types of scopes. There's Dobbs, there's refractors, reflectors. You can try all kinds of different things, different levels. And it's a fantastic way to either get to learn how to use a telescope, try one out. You know, everybody knows they can range in ridiculous prices. Just kind of see where you want to go with that. So
one of the best things about the loaner program, and I've had this told to me a couple of times, is to paraphrase someone, they'll say that they didn't know what type of telescope they wanted. And
for sure.
I suggested to them to try one, another one, try another one, come out to the public nights, which unfortunately we're not having right now, but come out to the public nights and just take a boo through different telescopes.
Yep.
Talk to the people that own them, figure out which ones you want before you go out and spend the money.
Yeah. And the nice thing is, with the exception of 1 or 2 of them, they're all very user-friendly. If you've never used a telescope before, you can get right into it right away. So.
And if you're not familiar with telescopes and such, that brings us to my second thing. One of the other things, benefits of belonging to this organization is we do offer educational programs. One of which will be starting up in about 2 weeks or so. It's what we lovingly call the Astro 101. It consists of a series. Right now, I think it's about 10 episodes or 10 sessions every other week or so on a different topic of introductory astronomy, or what would be the word? Stargazing would be the other word, to help you learn to figure out which end of the telescope to look in, right up through what to expect to see when you look out, and what ways to record what you do, how to learn from them, and sometimes even what awards you can win or earn, I should say, by following goal-oriented observing programs. Those are, as I say, that one's starting up in about 2 weeks. Sue, if you could type an email address for that, astro101@amateurastronomy.org. See, we'll put that out as a chat to everybody. If you're interested, send an email there. That'll get to John, and John will take care of you there. Let's see.
Bernie, can I just,
Yes?
I'll throw the email into the chat as well for the Lunar Scope program if anyone's interested in asking me some questions.
Absolutely. Sorry. Let's see. In February, next month, we're going to do something a little bit different. Instead of having a scheduled speakers like we have Paul tonight or Dr. Delaney, we are going to have what we haven't done for quite a while, which is a speakers night. We will have a couple of different members give 5-10 minutes on speaking about their love of astronomy, seeing that it's so close to St. Valentine's Day. So we'll talk about the love of astronomy. And the floor is open if anybody has a particular little anecdote, just a couple of minutes that they'd like to share, or a photograph or a sketch or something, or they went to an observing site in the middle of February and they managed to lock themselves out of their car. Anything like that that tells us a little bit about you or some of your experiences. Give me a shout. That's again, throw that on there for me too, please, Sue. That's chair@amateurastronomy.org. So far we have 3 people so far. And there's a couple of minutes apiece, 5-10 minutes tops, maybe 15. We can round it out pretty easily with just a couple more people. Anyway, back in March the 5th in 2017, 100 years ago it seems almost, a group of us were out at Grimsby on one of our outreach events. And whilst we were there was another part of our club went north of the city to observe an occultation. The group in Grimsby, we just saw an ordinary occultation. The other group saw a grazing occultation. And what the heck is that? Some of you are asking. And why is it important to me? Well, we have Dr. Paul Delaney with us tonight, who is a great friend of this club. We appreciate his partaking with us.
You're the only kid.
Pardon me? Oh, okay. Dr. Delaney has numerous awards, including the Sanford Fleming Medal for outstanding contributions to the public understanding of science amongst Canadians. And I think that's one of the best awards you could get. Anyway, he is here he has been a member of various RASC groups. We won't hold that against him. We love the RASC since 1980 or thereabouts. And as I say, has been a good friend of the HAA for many, many years. He is here to speak to us on the topic of occultations and why we sometimes say peekaboo when we're doing this. Dr. Delaney, the floor is yours.
Thank you very much, Bernie. All right. Well, first things first, before I start talking, let's make sure that I can bring up the presentation here. So let me just go and find it.
And Dr. Delaney, as you're doing that, I'm just going to ask everyone to please make sure they are muted and that their cameras are off.
Okay. All right. So can everybody, hang on, let me just now do this. Dum-dum-dum.
And yes, we can see your slides.
Okay. So the question is actually, do you see one slide filling the entire screen or do you see my notes?
We also see your notes.
Okay. All right. So let's just
I think you're in presenter view.
I am. Okay. So hang on. Let me just see if we can.
From current slide.
Okay, stop sharing. Okay, so hang on. Let's bring this over to here. Bear with me one moment. Haven't done this for a while. Okay, I think I've still got the problem. You're not seeing the full screen yet, are you?
No, and we're still seeing your notes as well on the side.
Right. Not that there's anything there that I don't want you to see, but I would like to have the whole thing for you. So hang on.
Yeah, you have to disable the presenter view.
Well, I've got two screens, so I'd like the presenter view to be active.
Yeah.
But I should still be able to have.
To share your other screen.
That's right. So that's
yes.
the trick here. And aha, I think I have solved it.
Yep, we're good. We're good to go.
Okay, patience 'tis a virtue, possess it when you can. Okay, so thank you once again for inviting me to chat with you folks. And as Bernie indicated, peekaboo, the value of occultations. In fact, as we go through the presentation, one of the things that you will find is that this was one of my earliest memories of doing, shall I say, amateur professional work. So occultations are near and dear to my heart, and hopefully by the end you will have a better appreciation of it, and maybe, just maybe, you'll dip your toe in the water of occultation activity. All right, so now having said all that, let's see. Right, first off, of course, I've always got to give the quick ad. Okay, the Alan I. Carswell Observatory, home. You saw the 1 meter telescope behind me. Lots of opportunities to connect with the observatory. And even though I am now officially retired, it doesn't mean that I have given up my key to the observatory. And of course, there's still lots of activity there, which is being marshaled by my successor, Elena Hyde, and all of the students. Monday evenings, York Universe radio broadcast. You can also participate in the online public viewing. We transmit live images from the 1 meter telescope when it's clear. And then on Wednesday evenings, we are allowed once a month to bring people in person to have a look through the 1 meter telescope. And you can sign up for that. It's obviously strictly controlled, COVID protocols, et cetera, et cetera, et cetera. But by all means, all that information, observatory.info.yorku.ca. And there is our 1 meter telescope. It was installed in August of 2019. And it is active tonight. We've got an observing team there photographing the James Webb Space Telescope. They are really pumped to go photograph it. So as I say, if you have an opportunity to visit us in person, that's great on a Wednesday evening. Otherwise, touch base with us on a Monday evening for the online public viewing. Okay, so let's start off with what the heck is an occultation. And so the standard commentary, Wikipedia, dictionaries can deliver it pretty well as well. An occultation occurs when an apparently, important point, larger body passes in front of an apparently smaller one. Lunar occultations are the ones that most people think of. That is to say, you're looking at a star and the moon's path, its orbital path around the Earth, carries it across that star, so the star blinks out of view. When you think about it, the moon must do this a lot, and it does, because of course it's half a degree in diameter, and it therefore has the opportunity to occult, to block out the light of the background stars. Obviously, the moon appears to be much larger than the stars. The stars appear to be point sources, but all of us on this broadcast know full well that the moon is tiny compared to the size of a star. Hence why in the definition, we're talking about apparently larger and apparently smaller. The moon, though, is not the only object that can occult a star. Planets, despite the fact that they look point-like to the naked eye, are not points. And any of you who have turned your telescopes on planets know full well that they subtend, they have a specific size. It's often measured in a few tens of seconds of arc, particularly for the larger gas giants. And that means, of course, they have the opportunity as well to occult a background star. Because these objects, planets, are much smaller and asteroids smaller still, the chances of them occulting a star, let alone a bright star, relatively small. But nonetheless, as you will see in a moment, planetary occultations are really, really valuable. And that's not to say that lunar occultations are not, but arguably the planet and asteroid occultations are even more valuable. So these are apparently larger objects: the moon, the planets in our solar systems, the asteroids, dwarf planets in our solar system, moving across and blocking out the background starlight. The moon's orbit, of course, moves from one side of the ecliptic to the other. In fact, you can block out, you can occult stars from the moon if you are looking at a star which is within 6.5-ish degrees of the ecliptic. The ecliptic, of course, is the orbital path of the Earth around the sun. The moon bobs up and down with respect to that ecliptic. That is to say, the moon's orbital path about the Earth is not coplanar. It is not in the Earth-Sun plane. And as a consequence, it, as I said, can bob anything up to 6.5 degrees above the ecliptic to 6.5 degrees below. It's quite a swath of stars, therefore, that the moon can occult. Within that band, of course, all the planets in our solar system reside. So that means the moon can run across the planets in our solar system. Most, but certainly not all, of the asteroids and the dwarf planets in our solar system can be occulted by the moon. And the four bright stars, Regulus, Spica, Aldebaran, and Antares, they can really put on a show when the moon occults them. So all of the objects within 6.5 degrees of the ecliptic are therefore potential targets for lunar occultations. Just to give you a couple of examples, you can see the bright star Aldebaran over there on the left-hand panel, and it is approaching the dark limb of the moon. So the moon is moving in this image from left to right, and very shortly, Aldebaran will be occulted by the dark limb of the moon. That's the easier version of a lunar occultation to be able to see, because of course the dark area of the moon, the unilluminated area of the moon, is therefore a nice contrasting backdrop to the brighter star. Much harder, but not impossible, much harder to observe a star as it is being occulted by the bright limb of the moon. So obviously that's a function of phase. The right-hand image shows you a fairly spectacular occultation of the planet Saturn. And because Saturn has a distinct diameter, it has an angle that is being subtended about 10 arc seconds, 10 to 15 arc seconds, especially when you include the ring system, you can see that it takes a perceptible amount of time for the moon to run over Saturn. So a more spectacular example of a planetary occultation from the moon's perspective. Okay, so I've hopefully given you a bit of an insight into what a lunar occultation is. How do you go about observing it? Okay, well, number of things that have to happen. And Bernie actually already implied this when you did that observation back in 2017. The two observing groups were only separated by maybe 100 kilometers, I don't know, perhaps less. One group of observers saw a regular occultation, and the other group saw, and I'll explain this in a moment, a grazing occultation, a subtly different observational event. So the location that you end up at is really quite important. And the location is not just within a few tens of kilometers of your home base, but in fact, occultation observations are taken by people all across the globe. And at those differing latitudes, differing longitudes, as you will see in a moment, it really can build a big and important picture with respect to the object that is being occulted. So being in the right place at the right time, really very, very important. You need to have a recording device, a time, the timing of the occultation is exceptionally important. We're not talking about a few seconds accuracy here. We're really talking about a few tenths of a second of accuracy if you can manage it, and even better, and that's now in fact practical with modern computer technology. So a recording device of some description and a very accurate time source, not to mention a telescope. I'm going to show my age here because when I started doing my occultation measurements, the recording device was a tape recorder, a cassette recorder, portable cassette recorder, and the timestamp was being supplied by a shortwave radio that was tuning into a radio station that gave out time pulses every single second. And so my observations, my voice of what I was actually observing was being recorded on the tape recorder, on the cassette recorder, along with the timestamp. So that after the actual observation event, say for example, an occultation of a star by the moon, you would be looking at the star, you could see the moon approaching the star, you would be calling out commentary, I can still see the star, I can still see the star, and then all of a sudden the star will literally wink out of existence from your perspective because the moon is now blocking that light. And at that point you go just, ape wild and go, yes, yes, it's gone, or something similar, so that it's all captured on the tape recorder, and then you go back after the fact and you can measure to within, generally speaking, a fraction of a second when the actual occultation took place. Now, as I said, that took place for me back nearly 45 years ago now. And I remember it ever so clearly because I was sharing the field with a bunch of cows who were really wondering what the heck I was doing there. They were quite placid. They didn't bother me in the slightest, although I did keep my other eye, the one that wasn't used in the telescope, on them just to make sure that they weren't going to get frisky. At any rate, now, of course, it's a whole lot easier. You still need the telescope, but generally speaking, video images, some sort of webcam device in the eyepiece, you're monitoring that on your computer terminal, you're recording that information, and either the accurate timestamp from your computer system is either being visually imprinted onto the video signal, or of course is being time-stamped every time you are taking an image. So regardless, you're talking about being able to record when the actual occultation takes place. And the more accurately you can record that, the more valuable is your observation. Okay, so you're standing out imperiled by these cows in the field and you're going, well, why am I doing this? Well, there are several possibilities. One, you just like observing the moon out in the middle of nowhere in the company of other strange animals. Or, of course, there is a more scientific reason. The multiplicity of stars can be found very easily during occultations. Many, many stars that were thought to be single stars were deemed and determined to be multiple stars by the fact that the moon occulted them. Because invariably, the moon takes a moment or two in time to move across the expanse of two stars separated even by a fraction of a second of arc. And so you can see one star of the multiple system dim out, and then if it's just a binary star, then the second one will dim out. And in that brief moment, that might only amount to 1 or 2 seconds, a single star has revealed itself to be a multiple star system. And of course, depending on how far they are separated, based upon the apparent motion of the moon, you can determine very quickly and fairly easily the separation of those two stars. And then you match that up with other, perhaps radial velocity information. You can determine, therefore, the characteristics of the orbit of those two stars. Very, very straightforward way of determining the multiplicity of a star. Let the moon run it over. If, of course, you've got a very high precision setup, then in fact, you can actually measure the diameter, the real diameter of the star. You'll be measuring that in, generally speaking, milli-arc seconds, so a fraction of a second of arc. And so stars, the larger stars in particular, can often be viewed using this type of a technique, and you time how long it takes from first contact, the moon's limb with the star in question, to the second contact when the star is now completely immersed, covered by the advancing limb of the moon. Once you determine that amount of time, given the apparent angular movement of the moon, then you can convert that to an actual diameter in milli-arc seconds for the star. We have measured many star diameters this way. And that is a wonderful way for us to then go back and actually check. Once you know what the intensity of the starlight is, you can actually work backwards and determine what the temperature of the star is. And given the fact that there are other ways that we are able to determine the temperature of a star, this gives us sort of secondary checks. So knowing what the real diameter of a star is in milli-arc seconds, know what the distance of that star is, or conversely, calculate the temperature, see how that compares to other observations, and then go ahead and determine the distance to that star. There's lots of fundamental astrophysical properties that you can determine by something as simple as determining the real diameter of a star. Radio sources, they are often extended, and the actual radio source itself is often almost impossible to see optically. It may be immersed in a lot of dust and cloud or other material that makes the determination of where the actual radio source center is located almost impossible. And so if you are lucky enough to be able to have the moon occulting this radio source, then again, the exact position of the radio source can be determined based upon when that source disappears, shall I say, from the observer's perspective. This is where you marry radio observations with optical observations. Now, I did mention grazing occultations. Bernie mentioned them earlier. Obviously, if the moon is moving around the Earth in its regular orbital path, and it is running over a star, it's occulting the star, then you can imagine the situation where the moon just manages to occult the star. That is to say, the star moves across the limb of the moon. So it doesn't actually get occulted by the main body of the moon, but rather tangentially slides across the limb of the moon. When that happens, now you have the opportunity, the possibility of the surface lunar topography allowing you to see the star literally wink in and out. You can imagine that as the star is moving across the lunar limb from your perspective, as the starlight disappears, it's sliding behind a large mountain. And then, of course, beside the mountain is likely a valley. And so the star comes back into view. And so the starlight can wink, blink in and out for, many, potentially tens of seconds, depending upon the angle that it is just grazing the lunar surface. Depending upon where you are on the surface of the Earth, then that star might cleanly miss the moon's surface, including all of the mountains on the limb. Or, of course, it might slide completely behind the moon's surface itself, therefore, again, not revealing the mountains and the valleys. Those are your two extremes. If you've got observers spaced out in latitude between those two extreme observations, then you can actually map out very, very accurately surface topography. This technique has been used by amateur astronomers in particular for literally close to 60, 70 years and was very valuable in the run-up to the lunar landings in the late 1960s and early 1970s. As NASA was preparing its possible list of landing sites, they utilized grazing occultations extensively so that they would have a better appreciation of the mountainous structure, the topography that the Apollo astronauts may need to navigate as they come from orbit down towards the lunar surface. So just a few of the possibilities that science can glean from occultations. Of course, if we're talking about asteroids or planets that are now being occulted by, if we're now talking about stars that are being occulted by planets or asteroids, then there's a lot more information that we can get out of those types of observations. In particular, we can actually get a physical interpretation of what the asteroid may look like, because an asteroid is anywhere from a few hundred meters to a few kilometers in diameter, perhaps a few tens or hundreds of kilometers even. If you are part of an observing team on the Earth, and those observers are spaced out across a number of differing latitudes, then in essence, each of those observing teams will be able to observe the starlight as it cuts through differing lines, differing diameters through the actual asteroid. And so you can build up a two-dimensional picture of that asteroid from the observers scattered across differing lines of latitude here on the surface of the Earth. And so you end up with dimensional information. Of course, dimensional information coupled with estimates of the density allows you to determine the total mass of these objects. If it's a binary asteroid, then of course you'll have an estimate of the mass, and that in turn can give you an accurate determination of density and so on. And of course, if it's a planet that is passing in front of a star, then the starlight will dim as the light passes through deeper, thicker portions of that planetary atmosphere. And so again, you can gain insight into the properties of the planetary atmosphere, its density, indeed its composition, by watching these planets slide across in front of background stars. So there's lots of really good science that can be generated from a very straightforward observation. Well, let me give you a couple of really recent examples of absolutely stunning and unexpected occultation results. The Uranus Occultation of 1977, the SAO star that you see there, was being occulted by Uranus on March 10th, 1977. The observations of this particular event were going to be taken from the Kuiper Airborne Observatory. This was NASA's precursor to SOFIA, the stratospheric observatory of modern day. The Kuiper Airborne Observatory came to Australia. In fact, it came to Canberra. I actually went through this vehicle just prior to it taking off to make this observation. I was a member of the Canberra Astronomical Society at that point in time. We were able to literally get a guided tour of the KAO, a phenomenal telescope facility, and it flew at in the vicinity of 15,000 meters. The observing team was from Cornell University, just across the other side of Lake Ontario here in Ithaca, New York, and they were wanting to look at the atmospheric properties of Uranus. They got far more than they were anticipating. So this is a quick representation of what's going on. You can see the star heading towards Uranus. That's the brighter point of light there. And you'll notice on the bottom graph that the starlight is winking out long before it got to the planet itself. And then when the star came out the other side, it saw again a symmetrical set of winks, if you will, or disappearances. This was completely unexpected. We were expecting to see the star disappear behind Uranus, so that was expected. What we didn't expect was to see the starlight being blocked by successive motions behind various ring structures, rings that we did not even know existed around this planet. Up until this point in time, Saturn was the only gas giant in our solar system that was known to have a ring system. So what we've now got here is a diagram showing you the motion of the Earth. And remember, it's the Earth that is doing most of the movement here. It's looking at a distant star. And as it observes that starlight passes through the various rings that are surrounding Uranus, long before it got to being occulted by the planet itself. Needless to say, the observers were absolutely ecstatic once they figured out what the heck was going on, because it was a very fundamental observation, a very simple observation that yielded a terrific and unexpected result, the rings of Uranus. Shortly after, in 1986, Voyager 2 flew by Uranus, and it measured 13 distinct rings orbiting around that planet. Very dark particles, relatively small material. Generally speaking, the largest chunks in the Uranian ring system are about 1 meter in diameter. Most of the stuff is of order micron. So it's really, really fluffy type stuff, much less grand than the rings of Saturn. But doesn't matter. It was a ring structure. The rings themselves were a few kilometers in diameter. And not surprisingly, the material that we're looking at here is primarily a variety of ices, methane ice, carbon and silicate grains, and we now are of the opinion that the more distant material in the ring structure is probably water ice. Big question with all ring structures is how old are they? Generally speaking, ring systems are not believed to form with the planets. So back 4.5 billion years ago, the gas giants formed as planets, but the ring systems arise from catastrophic collisions of moons that are orbiting those planets with other objects, the shattering of the satellite or its encroachment on the Roche limit, point where gravitational disruption takes place, is what we believe is generating the ring structures of all of the gas giants. Since then, of course, we've got the Hubble Space Telescope, and it's able to image the ring systems directly. You can actually do it from Earth as well, but it's a whole lot trickier to do and does require some fairly sophisticated equipment. But here you see a number of images, shorter exposures closer into the planet itself, and then longer exposures further out to show you the ring structure. Of course, Uranus, we could talk about for most of the evening. It's a barrel rolling planet. Its rotation axis is tipped over 98 degrees compared to the ecliptic plane. So literally, it barrel rolls its way around the sun. You can see the pole here being illustrated. The ring system is surrounded by the 27 satellites that orbit around Uranus. Many, many of them are quite small, only a few kilometers to a few tens of kilometers in diameter. And it is those shepherding satellites that corral and maintain the ring structures. This is true of all 4 ring structures: Saturn, Uranus, Neptune, and Jupiter. Just having a quick sip of water to keep dry. So once we realized that the Uranian ring system existed, the questions arose around Neptune. In fact, there was a suspicion all the way back in 1968, 10 years, nearly 10 years before the Kuiper Airborne Observatory flew to find Uranus's ring structure, there was a suspicion through an occultation measurement out of New Zealand that Neptune may have had a ring structure. Given what was found for Uranus in 1977, there was determined to be another occultation in 1984 that would hopefully put to rest the question of whether or not Neptune had rings. Well, unfortunately, that observation in 1984 produced some really odd results, and it coined the term ring arcs. There was a suspicion that Neptune did have a type of ring structure, but that they were not complete rings. They had significant amounts of gaps within them. And so the occultation observations were passing through thicker and thinner, perhaps non-existent, sections of the ring. It took, for Voyager 2 in 1989, to put to rest the question of whether or not Neptune did have complete ring structures or whether or not they were ring arcs. And the answer was, courtesy of the Hubble Space Telescope, this image, a series of images, that Neptune has indeed a series of rings. Even finer material than Uranus, probably an even younger system, but nonetheless, there were ring structures around Neptune. It was the last of the 4 planets in our solar system, the gas giants, to have a confirmed ring structure. And like Uranus, like Saturn, like Jupiter, it is the small shepherding satellites that help corral and choreograph the ring system structure. So again, occultation measurements came to the fore here in giving us an understanding of the ring structures of Uranus and Neptune. A little more recently, the New Horizons probe. That was, of course, the vehicle that shot past Pluto in the summer of 2015. Did it wonderfully successfully, but even before we got to Pluto, everybody realized that New Horizons was in terrific shape. There was going to be onboard propellant left over after the encounter, and so quite rightly, they sort of said, okay, where to after Pluto? And so there was a search by the Hubble Space Telescope in 2014 to look for a Kuiper belt object, basically a small asteroid, that was on the projected path of New Horizons that it would be able to encounter within a reasonable period of time. That is to say, while the spacecraft was still in good operational health. Hubble was successful. Mark Buie was able to identify an object. You can see it there, 2014 MU69. It was just beyond the orbit of Pluto. And in August of 2015, it was decided, after the Pluto encounter, that New Horizons would continue on to 2014 MU69 to be our first encounter with a Kuiper belt object, other than Pluto, and that there was sufficient onboard propellant, a sufficient health for us to expect a reasonably good intercept. That intercept was to occur on January 1st, New Year's Day, 2019. The Kuiper belt object in question was about 40 kilometers in diameter. But other than that, we knew next to nothing about it. Yes, it had a 298-year orbital period. Yes, it was about 40 kilometers in diameter. And literally, that was it. It's just too far out and too small for us to get a whole lot more information. Hence the value, the importance of the New Horizon mission. However, there was an occultation in July of 2017 where 2014 MU69, and now let's call it by its proper name, Arakoth, when Arakoth was going to occult a background star. And this gave us the opportunity to get some fundamental information about Arakoth in preparation for the New Horizons flyby. The top image, if you look at the very central point of light, you'll see it blink. This is on a continuous loop, so just watch it there for a moment. That is the background star, and the blinking which is happening is a result of Arakoth passing in front of it. This is a real-time observation. So as you can see, Arakoth blocks that light for considerably less than 1 second. But that was more than enough for the amateur and professional observers who were spaced out mostly across South America to get a really good picture, or at least silhouette, of what Arakoth would look like. And you can see here the 7 observational paths, which these were where observers at differing latitudes on the Earth were observing Arakoth. And you can see where the black is, that's where the signal drops out as a function of each of the observers' locations. And you can get the overall sense that Arakoth really looked a little odd. This is what the projected observation was going to look like on the right. The image on the left was one of the early approach images of New Horizons to Arakoth. Remember, we're talking about an object that is 43 times the distance the Earth is from the Sun. So the fact that New Horizons was actually able to observe it is pretty darn good by itself. as it was getting closer to it on New Year's Day 2019, people began to have a bit of fun with it. And you can see the snowman illustration there on the left. The image on the right is a real image. It's not the closest approach image, but it is a real image of Arakoth. And, oh, I'm sorry. You can see that it is, in fact, a binary asteroid, what we call a contact binary asteroid. It's about 36, 37 kilometers long, and the bottom section is about 21, 22 kilometers in diameter. This was, in fact, one of the close approach images. The color rendition is very accurate. It's a very dark object. It has a very low albedo. The image was taken from a distance of about 3,500 kilometers. And what always astounds me is that it is so sharp and clear, given the fact that New Horizons was moving along at in excess of 52,000 kilometers per hour. Pretty amazing image from New Horizons. But if you go back and think about the observations of those amateur and professional astronomers using occultation measurements, they got the shape of Arakoth really very, very accurately. Just for comparison, there is Pluto. Pluto is about 2,500 kilometers in diameter, just under 2,400 in fact, whereas Arakoth is only about 40 kilometers in diameter. New Horizons really had to be on its game to be able to generate the types of observations it successfully did. The point I want to make here is that amateur astronomers are the ones who generate the vast majority of occultation observations year in and year out. Remember, I said you have to be in the right place at the right time. Generally speaking, that means professional observatories are cut out of these types of observations, or at least the more important observations, because they can't move. You can throw your telescope in the back of a car. With modern laptop technology and so on, video technology, you can go just about anywhere and make an observation at any time of the day or night. And of course, you can chase those clear sky locations. Again, professional observatories cannot. Professional telescopes are able to make observations, don't get me wrong, and many do. But of course, there is a much more limited opportunity for them to do so because, as I said, they are in fixed locations. That is not the case for amateur astronomers. And so amateur astronomers have owned these types of observations now for well over the last 60 years. With the improvements in modern technology, laptops, CCDs, and so on, you are able to have far greater reach than you were able to 40 years ago. I remember staring into my telescope and getting really annoyed about the bright limb of the moon. But of course, now you've got all sorts of capabilities with video technology, which can capture that information, a variety of different exposure times, including fractions of a second, so that your temporal accuracy for these observations is second to none. And you can go back and observe at time and the recording time and time and time again. And of course, the precision with which you can timestamp those observations is just excellent. When all is said and done, looking at lunar observations is fairly straightforward. I mean, you can't miss the moon in the sky, right? All you have to do is know approximately where a disappearance or a reappearance is going to occur for a star, and that just means know a little bit of lunar topography. Where is the north? Where is the south? Roughly speaking, we will tell you where the star will appear or disappear based upon an angle away from true north. It's really easy to make an occultation measurement. You just need a little bit of practice setting up your telescope in an unusual location. Make sure that you've got enough power source available to you for your laptop and your video camera. And as I say, know exactly where you are. And that's GPS these days. So it is really stunningly easy to be able to figure out where you are, get all of your observing equipment there, and make these observations. And you thus can contribute in a very, very significant way to a variety of differing astronomical puzzles. You're not alone. The IOTA crowd, the International Occultation Timing Association, is worldwide. And you've got the links here to a couple of their main sites, North America and Europe. these are the folks who can give you insights into when occultation observations could be made. They can project into the future. So year by year, they'll tell you where for your location observations are going to be, both lunar occultations as well as asteroid occultations. If you've got a slightly more sophisticated setup with a little bit more aperture, then you can always sign up for a variety of differing asteroid occultations. Depends what your equipment is and what your interest level is. But IOTA is the place to go. And as I say, something for everybody there. It really is that well equipped for all level of amateur astronomers. There is a journal there that you can read up on. The observations that other people have made worldwide, the challenges that they have engaged in, the excitement that they have generated in these observations. And of course, that's where your observations can be published. So if you do go out and make a set of observations, either by yourself or in combination with others at the club, then submitting those results and perhaps writing up a story about it can end up in the IOTA newsletter. So lots and lots of ways that you can contribute in a very significant way to astronomical observations. Just as a closing thought, I've spent obviously a lot of time tonight talking about occultations, the opportunity for the moon, for planets, for asteroids to occult, to block out the light of background distant stars, and the value to science that those observations can make. When you think about it, though, occultation and eclipses are connected together. The eclipse is, in fact, in many ways, the reverse of the occultation. So the eclipse is taking place, well, when you think about a solar eclipse, you're talking about a smaller object passing in front of the larger object so that you don't necessarily block out the entire background object, in this case, the sun. When we look back over the last 30 years, these types of occultation eclipses have been terribly, terribly valuable to us. Exoplanets, I've spoken to you about exoplanetary observations in the past, but just as a reminder, the transit technique, which is by far the most successful at finding exoplanets, is when a smaller object is passing, the planet, is passing in front of its background star. And in this case, it's not so much the light dipping out or winking out, but it's just decreasing. The light curve that you can see at the bottom of this diagram is showing what happens when you drop out just a small portion of the star's light from our perspective, and that dip during the transit allows us to go ahead and make all sorts of fundamental measurements, not the least of which is the diameter of the planet in question, potentially the diameter of the star, especially if we know how far away it is. So occultations and eclipses have become really the mainstays for a whole host of astronomical observations. The differing sizes of stars, the differing speeds with which planets are moving about their parent stars, which in turn is related to how far away they are from their star. All of this can be made by these types of transit or eclipse types of observations. The Kepler satellite, by far the most successful of all of the instruments that have gone out to look for exoplanets. It's no longer operational. You can see there it operated from 2009 through 2018. Roughly speaking, 5,000 exoplanets were found by this satellite. And there are several thousand more candidates that are still being examined. Given the fact that we were hoping that we would find a few hundred exoplanets with Kepler, and that we have found many thousands, so 10 times more than we were expecting, shows you the value of a fairly straightforward and simple type of observation. The successor to Kepler is the TESS satellite, the Transiting Exoplanet Survey Satellite. Very different architecture. I'm not going to go into it. But again, the idea of blocking out starlight so that we are able to make fundamental observations, in this case for the determination of exoplanets around parent stars, all comes down to very straightforward observations. So I would strongly encourage all of you to think about becoming a part of the occultation observing family. because it can be not only very satisfying, it's a great way to contribute to science. Thank you.
Well, thank you so very much, Dr. Delaney. A terrific presentation. Oops. I cannot stop my video because the host has stopped it. Okay, whatever. I believe you'll be open for questions.
Oh, absolutely. Yes, indeed. No problem there at all.
Okay.
Moderate who actually asked the question.
You can either speak up or you can text your question in to Sue, and Sue can moderate, as she usually does.
You know what, Bernie, it's easier if they put them in the chat. And,
Yep,
and I
okay.
moderate with a big group. It's easier to do that. And I've asked you to turn your video on, so you should be able to do it now.
Okay, oh, there it is. Good, thank you. There I am. I'm hiding in the shadows of the moon.
That's right, you're eclipsing the moon.
Yes, I'm occult. Yeah, there you go.
So we'll give people a minute if you want to type your question into the chat. And I will ask them as I see them.
Okay. Back in 2017, Paul, when we were doing this occultation deal, it was one of the very few times that it happened to be on a night that was clear and a night that everybody was going to be out anyway.
Good timing.
Yeah, it was Aldebaran was the.
Oh, it was the Aldebaran observation. Okay.
Yes, that's what that was. That was an awesome event. I don't know if the group that went to do the Grays did the actual timings and stuff. I certainly hope they did. I mean, what would be the point otherwise?
Well, it's a neat observation to make, and certainly relatively rare to see a graze of a bright first magnitude star.
Yeah. Well, when you see it going in and out of, like I've seen others, I did not see that particular graze because obviously I was not there, but I've seen other grazing occultations, and when it's coming in and out of the mountains, that's definitely where you get the peekaboo from.
Correct. Correct.
Okay.
Bernie, at this point in time, I don't see any questions in the chat, and I haven't had Chris send me any questions from our YouTube viewers at this point in time.
Okay, well then I'll have a question for Paul.
Okay.
As amateurs, what would be the, now I already know the answer to this, but what would be the smallest equipment that you could use to get meaningful observations? And I'm talking the optics, not the timing mechanism.
Right. I mean, the vast majority of stars that do get occulted are relatively faint. But, you know, when you're getting down to 8th, 9th, 10th magnitude stars, that's easily within the reach of, you know, a 6-inch telescope. No question in the world about that. The biggest challenge is whether or not it is a dark side disappearance or a bright side. And the bright moon is really a big problem. There, actually, smaller apertures are arguably better. So there's no one size fits all answer here. If you are going to register your equipment or register your interest with IOTA, they will send you down to potentially 10th, 11th, 12th magnitude stellar occultation opportunities. And then it's really up to you to decide whether or not your equipment is going to, you know, be up to that task. But as small as literally, you know, a 6-inch telescope, you know, 15 centimeters, is going to give you a raft of observations to make. The larger the aperture, the fainter the star that you're going to be able to collect and therefore observe. So it really is a function of your interest level. And obviously, you will get better at observing these types of events. Your eye will become acclimated better over time. And so your ability to take in fainter objects, even with the same telescope, will improve as you do these things more frequently.
I have a question in the chat from Doug Turner. Have the occultations and transits of the Jovian moons revealed anything unexpected?
Well, if you go back to the 1600s, when we were actually figuring out Kepler's laws, the observations of those transits and eclipses gave rise to an accurate determination of the speed of light. So for 400 years, these types of observations have been very, very valuable. To the best of my knowledge, the orbital paths of those objects have not given us any surprise results as a result of eclipses or occultations. Of course, the Jovian satellites are doing that with respect to Jupiter all the time. And sometimes you're lucky enough to actually see one of the Jovian satellites pass in front of or behind one of the others. None of them have atmospheres. So, of course, there is no information that we can gather as a result of those types of changes. So to the best of my knowledge, you're really asking the question, have the orbital paths of those objects been detectably in error or at variance with what we were expecting with respect to occultation or eclipse observations? To the best of my knowledge, and I'm not going to claim to be definitive in this regard, but to the best of my knowledge, the answer is no.
Okay, thank you. And I don't see any more questions, Bernie.
So, as everybody knows, well, not everybody here, but most of you know, I am a great fan of the Astronomical League's observing programs. And yes, they do have an observing program for occultations. And I just posted that link in the chat. You can go there, you can check it out. It also has a lot of information about the who's, what's, and wherefores of IOTA. Again, it's another one to go take a look at. It requires a certain number of observations and stuff, but anybody who wants to try it, that's a great place to start. Because you start off with, I think it's a half a dozen or so lunar occultations, and then you get into some planetary, and further on you get into the asteroidal. And they even go so far as space junk, which can be interesting. But anyway, yes. So that's, I threw that up there if anybody wants to get involved with that or at least take a look at it. Anyway, if there's nothing else, I will thank you, Dr. Delaney, for joining us. You're more than welcome to stick around.
No, my wife would like to have my presence. So no, I will pass on that. Thank you.
Okay. Well, thank you again. I will be in touch with you in the next day or two, just to pass on some more feedback if I get any.
Okay. And if anybody has any questions, by all means, you've got my email address, and yeah, clear skies to you all.
Thank you very much, Paul.
Good night.
Good night. All right. So we're going to take our usual break. We're going to take a break for 10 minutes, well, 7 minutes now. We'll come back at 8:40 and we will resume at that point. In the meantime, get up, stretch, go tinkles, make your coffee, change your wine, whatever you want to do. Sit and talk if you like. We'll be back at 22. Hey, Mike, I see you made it finally. You got in. Nope, Mike's not talking to me. Nobody's talking.
Is my mic working?
There it is. Somebody's working. Who just asked?
Bill did.
Ah, okay. Yes, Bill.
There.
Your mic is working.
Yeah. Okay. Now you can hear me.
Okay, there's Mike. Yes.
There's Mike.
Oh, glad you could join us, Mike. I know you had a little trouble getting in this evening, but you made it.
Yes. Thank you. No, it may have to do with firewalls.
Yeah, probably.
And Lorraine, I did get your message and I'm glad that you got in as well.
did we get?
Thanks, Sue. I don't
Well,
know why I'm always having trouble until I go into Zoom itself, and it shows in small words, join a Zoom meeting. I click on that, and then I put the password in the ID, and then I'm fine. But I can't get it off of the email that comes from Bernie. I can't get in through that at all.
Okay,
Doug, do you think you know why?
It might be a space.
the easiest way, Lorraine, to get on that is if you can copy that link and
I
then
did.
paste it up into your bar, and that should get you.
I tried that, Bernie, and it didn't do anything either. It wasn't until I actually went into Google Zoom, and then in a bunch of little tiny headings, it showed join a Zoom meeting, and I just clicked on that. And then, like I said, I put the password and ID in, and I was fine.
That may be the way you have to go in the future.
I think so. I think
Yeah.
so. 'Cause this is
Doug-
the second month the same
Yeah.
thing happened.
Yeah, Doug said there may be, when you copy the link, you may accidentally get an extra character or a space or something when you copy it, depending on where your copy ends. And then when you paste that in, the link is wrong, so that it won't connect then. So if you can go in through the code and then the password,
Yeah.
then that's the way. And that Doug just said that's the way he does it all the time anyway.
And
He uses that. He doesn't. If the link is giving you issues, then that's the better way to go.
And it never used to. I used to be able to just click on that in the email.
Yeah. Zoom has also updated itself a number of times in the last little while. So you may want to run one of the updates. So if you have the client on your computer, there's been a number of updates. So you may want to run some of those updates. That might be another issue that might be happening.
Thanks, Sue and Doug.
No problem. Things
really good.
things to try to kind of solve the problem, right? So there we go. There we go.
So did anybody get a look at that moon this evening before the meeting started?
Yes.
No.
Yeah, I did.
Good.
Yes,
A brief peek.
Our
Yes.
so-called micro moon. Micro moon. That's crazy.
Well, it's in truth, it's a
Not
pavilion.
my name being taken in vain.
Yeah. Still about 28 arc minutes. It's not that it's tiny or anything.
I saw it at 3 o'clock. It was beautiful in against a bright blue sky when I was
Yes.
walking the dogs.
Here. Yes, yes. To all of the above.
The middle of the afternoon is the best time to look at the moon
Mhm.
because it's not as brilliant, or it is as brilliant, but you don't notice it as brilliant.
Oh, you just had
The best
surprise, we had blue
of the
skies.
day.
Had this weird thing called blue skies out there that you could, they weren't gray. There wasn't rain. There wasn't cloud. And I said I walked the dogs before the meeting, and yes, looked up and almost came home and got my camera and went back out to take some pictures, but it was too cold after walking the dogs for an hour.
Well.
I can't believe he went out without his camera. That's like heresy or something.
I know.
The dogs won't let me take my camera. They kind of look at me if I even think about taking my camera.
Well, they know that when you've got the camera, you stand still too much.
That's about the extent of it. The old boy will stand still. Jupiter will stand, and he probably isn't. He doesn't care. Lupus, yeah, no. At 2 years of age, we're walking, and that's where we're going. In fact, he's lying here beside us, and he heard that W word. Now he's thinking he gets to go again.
But we none of us should say the W word, right?
Come here. You gonna come up and get in the picture? No, that means you got to get off the floor.
Is Denise here tonight?
No, she's sitting beside me. Oh, she went and got a tea.
Oh,
She was sitting beside me. And he's lying between us.
Matthew, is Janice here tonight?
no, she's not. She's working her third night shift in a row.
Oh,
The
wow.
woman's a saint.
Yeah, they changed her days into nights. They were desperate for staff.
Oh. Yep. A lot of places are desperate for staff.
It's everywhere.
Yep.
Okay. I've got my coffee. I hope everybody's back. If not, they can catch up. Okay. Well, let's see. What do we do next? What's next? What's next? What's next? Oh, we have some draws to make for some books, etc. I'm going to turn off my background here, otherwise you're not going to be able to see the books. Choose background to none.
There he is, folks. There's Lupus.
Okay, so this book tonight is, oh, I'm going the wrong way, Meteorites, the story of our solar system. I believe, Lorraine, you just got this book
I did.
too long ago. How do you like it?
It's great. It's really good. I haven't gotten through a lot of it, but it's a good one to have.
Awesome, good. Second, we have Firefly's Night Sky Atlas, which includes some sky maps from Tyrian. There's a couple of, I've heard it pronounced several different ways. Lots of good maps and diagrams in here, good pictures, and so on and so forth. And last but not least, everybody needs a planisphere. Come on, get in there. There we go. This
I
is
only
the
have 6 of those.
Planisphere. Very easy to use. Good instructions here. Comes in a nice little packet case. Try to wiggle it around here so that people can see it somewhat.
It's one of the nicer ones to use.
Yes, it is. It has a plastic coating on it, which is great if you're starting to get into dewy situations. Anyway, those are the 3 for this evening. And at this point, I will turn it over to the family Whitman.
Hey, everybody, we're back.
Hello.
Scopes and prizes, if we give them all out.
Here, over here, there we go.
Okay. Okay, so for our first winner, we have Mike G.
Mike G.
Mike G.
Where's Mike G?
He should still be in the list.
Turn on your microphone and let us know that you've heard your name.
Mike G or T?
G. Like Gerald.
Yeah, I did.
Okay, we got 2 Mike G's. We've got a Mike G and Mike Griswold.
Yeah, so it's Mike G specifically.
Okay, so it's the one on my screen is sitting on top of Michael Jefferson's head.
But if we don't hear from Mike G, we could pass it off to the other Mike G.
Hello.
Oh, there we go. No, this is Mike Griswold, I think.
Well, what do we got here? We got about 50 people on this thing tonight.
We've got, right now we have 40.
Are my counts right? 40. My wife was very congratulatory just 2 minutes ago about how many people that we're getting, especially on this kind of a setup.
Mike G said on chat that he'll decline the prize, but thanks anyway.
Okay.
Yeah.
Thank you, Mike.
Okay, so then we'll just go to the other Mike G. I guess that's probably the sure. Why not?
Mike Griswold.
Yes.
You're a winner.
Hey.
Yay.
Okay, do we have your current contact information?
I believe you do.
So we're gonna need another. No, we don't need another.
Well, you'll have mine here before too long anyway. Should be on here somewhere already, somewhere in the chat. It's simple. It's chair@amateurastronomy.org.
Okay.
Do you just want people to contact you, Bernie?
Yeah, that'll be the easiest way. Leave me your phone number and I'll give you a call and we'll talk.
I'm putting it in the chat.
Okay, good, thank you. All right, next up.
All right, next up we have Dave Gaylor.
I think Dave is gone.
Oh, okay.
I
well-
could be wrong. Hang on, let's double check. Yeah, I don't see Dave unless he's got his camera on. No, I think Dave left.
Okay, well, in that case, we have Robert Richardson.
Now, Robert Richardson, there he is. I saw his microphone turn off. Say hello, Robert.
Hi, yeah, I'm here. That's great.
Yay! Okay, and lastly, we have Brenda Frederick.
Brenda.
Our recorder extraordinaire, I think.
Yes,
Yay!
she's not talking to us.
Too busy recording that she won the prize.
Could be, could be. Okay, I'll be in touch with Brenda.
Sure.
Awesome.
And that's it. Congratulations, everybody.
Yay!
The way that it works now is I will get in contact with you once you get in contact with me, and we will figure out how to get your prize to you. First come, first choice. Okay, so whoever's emailing me first, not on the group chat because it disappears as soon as we go off.
Okay.
Okay, so it has to be at the chair at amateurastronomy.org. Okay, first come, first served it. All right, so congratulations to everyone involved. I looked and I looked and I looked and I could not find a book in my pile of books that related to occultations. I'm sorry, I tried. Anyway, up next is our dear friend Matthew Mannering.
Yep, I'm here.
Out in the boonies. Well, not right out in the boonies, but out there.
According to Hamiltonians, anyways, I'm out in the boonies.
Yeah. So Matt, if you would take a moment or two to introduce yourself to our new members that are in attendance, and then you may proceed at your peril.
Okay. Yeah, I'm Matthew Mannering. I've been observing director for about 5 or 6 years in total now. Been on council since 2009. I am mostly visual astronomy. I do dabble in astrophotography sometimes throughout the year, but mostly I like to do visual. I have everything from a 12-inch Dob down to a little 60mm refractor, and they all have their place, and I really enjoy it. I'll be talking for the Astro 101. I'll be doing eyepieces and at least one other talk to be determined at this point, but I'll be there for definitely for 2 talks. And really that's about it. I'll turn off my video and share the screen.
And
All right, Bernie?
while Matthew's doing that, I'd like everyone to please turn off their mics and turn off their cameras. And when Matthew's finished, you can turn them back on. Thanks, everybody.
Okay, you can see me, Sue?
You're all good.
We're all good? Okay, so
Yes,
welcome.
Matt, you're good.
All right, thank you. Welcome to the sky this month for January 2022. Start off by talking about a very interesting evening we had last Saturday when Janice and I and Chris and Denise went to Stratford to look at the solar walk that's on display there. Now, being COVID times, we went in separate cars, but at least it's all outside, so we were able to walk together and have a really great time. The actual display, the solar walk, is on a little tiny island called Tom Patterson Island in the Avon River, downtown Stratford. And there's parking all on the other side of the river from the island, so it's easy to park. And you just get there by going across this little bridge you see on the left-hand side. All 8 planets are displayed and the sun is at the center. Almost all the planets have photorealistic surfaces, which is really cool. And they're really big, like 6 to 8 feet in diameter, most of them. Saturn, though, is terrible. I don't know what happened to Saturn, but it got a raw deal in the whole mix. But it's still interesting to look at. This is a view from the other side when we were coming back from downtown. And you can see pretty much everything here. There's Neptune, Uranus, Saturn, Jupiter. Peekaboo there is Mars, the Sun, Earth, Venus, and Mercury. And obviously there's a few pictures much closer up. Just a view right beside the bridge that my wife took. And you can see shadows of some of the people there, and it gives you an idea, a bit of the idea of the scale. Here we are on the actual island. This is sort of the back half of it, with the sun on the left, and then the inner planets all in a row down the right side. Even the Mercury, although you can't see it in any of my pictures because it always seems to be behind something, once you get up to it, it's very detailed surface rendition. The thing that was missing was plaques or any kind of information about what you were looking at, even the name of the planet. So it was really busy. There were a lot of people there, but a lot of people didn't know exactly what they were looking at. So that could probably be a bit better, but the idea is super, and it's pulling out a lot of people to look at this. Here you can see on the left, you can see Neptune and Uranus in the background. The reason we knew about this particular solar walk was because Joanne put out an email that talked about a kid 7 years old in Stratford who went on the walk with his mom and got to this part of the walk and said to his mom, "This isn't right. They've got Uranus and Neptune in the wrong spots." And of course she said, no, I'm sure it's correct here. Don't worry about it. But he persisted. And then she figured out that actually he was right, and they phoned the city, and the city changed them around. So that's pretty cool. Even if you're doing real visual astronomy, the colors here were actually pretty good, with Uranus being a greeny blue and Neptune being a much darker blue. The other thing you notice with Neptune is you can see the great dark spot. It's like the great red spot on Jupiter, but it's a storm on Neptune. On the right side here, you can see Venus. It was different than the others in that it's a radar imaging of the surface compared to a visual, like, normal look at the planet as we would see with our eyes. There's me beside Mars, so it gives you an idea of the scale of the planets. There's Olympus Mons over here, the biggest volcano in the solar system, and there's Valles Marineris over here, which is a giant gorge that's really as wide as the United States is wide. So it's a huge long canyon that runs like a scar across the face of the planet. There's my wife Janice. She's in front of the Earth. We were dressed up very warmly. It was right around 0 Celsius, and there was no wind, so it was very manageable to be there and then walk downtown and back, which is about a click each way. Now, on the left, underneath all these clothes is Denise, and she's pretending to be Atlas, I believe, and hold up the Earth, make sure it doesn't fall. And on the right side is Chris, being Chris. He's always fun, and we had a really good time with him. And yeah, we ended up actually on the way back, went back on the island again and looked around again and before we left. Now, you're going to go, you've got till January 28th is when it all closes down. But when you get to Stratford, you have to get to the river, and then you'll see this arrow's pointing to Tom Patterson Island. That's where the display is. It's not big island, it's very small. The parking is right across the road. You can see the P there. And then you can walk downtown all the way down here to the Shakespearean Gardens there, and they've got a light display there. Not too awesome, but nice. And then you can walk downtown to Marketplace. Now, the most important fact and piece of information you need to know about my whole talk tonight is that when you get to Marketplace, there are washrooms that are open to the public. They're at the front face of the City Hall there, and it's well marked, and you can go inside and use the facilities. There are no Timmy's downtown, so if you go and you're looking for like a coffee shop to get a coffee, there's not much there. A few fast food joints, but other than that, you're on your own. So I would recommend that you know about that spot. And in Marketplace, they also had some arches that they brought in from Australia, and really just great big blow up balloons. And they have sensors on them. And when you walk through them, it plays a nice soothing sort of chime or tone, and you can walk through all the different ones and all different sounds come out of them. It really was a little underwhelming as well as an adult, but the kids loved it. So, and the changing colors were really nice. So, you know, not a waste of time, just something a little different. Okay, I'm totally different. So I saw this picture on my phone on spaceweather.com, and I looked at this picture, and I have a very vivid imagination. And the first thing I thought was, who took the Harry Potter sorting hat and stuck it in front of the solar eclipse? And I'm looking at this thing and I'm thinking, what the heck? And then I actually read the actual the information about the picture and blew up the picture a bit. And of course, it's a penguin, right? It's not the sorting hat. It's a penguin doing ecstatic vocalization in front of the solar eclipse, taken in Antarctica. Really a cool picture. I showed it to my wife. I said, what do you think this is? She says, well, it's a penguin, of course. So well, there you go. And sticking with the sun somewhat, back on December 31st, there were two massive explosions on the sun. I mean, huge. And they were separated by 700,000 kilometers. The diameter of the sun is about 1.4 million kilometers, so literally half a sun away, basically. There was this flare, M-class flare, excuse me, that occurred here, which sent this gigantic magnetic ripple, unstable ripple across, and blew out this huge prominence here. Most prominences that I see in my solar telescope are about, oh, that big right there. This one is enormous. And here's a much more close-up picture of it, and that's where the M-class flare originated. Here's this enormous prominence. It's almost 700,000 kilometers itself. So that's pretty awesome. And with my imagination, I can see a person here with a hand pointing up there saying like, it wasn't my fault, it was them. At the moment, there's actually something just about to come around the limb of the sun. And it looks to be pretty intense. As you can see from my title there, Something Wicked This Way Comes. It shot out a couple of days ago, this huge stream of plasma into space, and then simultaneously blew out this huge expanse of gas from just about all the way around the sun. So it was an enormous explosion. And it should come around, whatever that is, a sunspot, I imagine, or a sunspot group should come around the limb in a couple of days at the most. So if you have any kind of solar telescope, have a look, or look online. Over here, you can see Venus is right at the edge of the field of view. This dark line is a stalk on the actual telescope with a disk here that blocks out the sun. There's the diameter of the sun and the area around it. Otherwise, you know, the telescope wouldn't work. It would just be blown out by the light from the sun. So they use this, an occulting disk, to block out the sun so that you can see the giant ejections from the sun, coronal mass ejections coming out from the sun. Also, we've had tons and tons of sunspot groups in the last few weeks. The most I counted was a couple of weeks ago, was like 7 groups. There's 5 currently there, although 29, 26 should be heading off into the sunset very shortly. If it comes around in 2 more weeks, comes around again to the other side, it gets a brand new number. They don't keep their designation if they turn around the other side, the other hemisphere, the far hemisphere, and come back again. Now, current upcoming solar maximum was supposed to be very, very like not very impressive, mundane, I guess would be a good word for it. And so what we've seen so far, and here's roughly where the previous cycle ended, and here we are going up into the current cycle. we're seeing twice as many sunspots at this point as we were supposed to be seeing according to the prediction, and this is the predictive curve here. Excuse. And so what I'm hoping is that this is going to continue, and we're going to have a curve that's like that. Should be awesome. There's already been some spectacular displays, and I'm kind of hopeful that we will continue to see that. And
So
James Webb.
Matthew, just to go back for a second, you were talking about the flare coming around the other side. I've been, or the image coming around from the other side, I've been watching on the stereo A. And
yes.
It is, if you remember a couple of weeks ago, we had the 3 big flares crossing the front of the sun on our side. It's those 3 are coming back around.
Well, either way, it's going to be awesome.
Oh yes, I'm waiting. I'm polishing up the eyepieces and I'm waiting.
Yeah, I'll be out there too if we get some sunshine to have a look, that's for sure. Anyways, James Webb, after just a few years of being delayed, is finally up in space. I remember being at Cherry Springs in 2015, I think it was, and the director at that point of this mission came out and gave us a talk. It was very interesting and said it would be up the next year, 2016. So they kind of missed it by a few years, but it is on its way. And it's just been an awesome mission so far. Everything has worked perfectly. The whole telescope has unfolded correctly. They're at the point now where they're starting to align, do some really sort of gross alignment of the mirror segments. Once they get them grossly aligned, they'll then start collimating each part, each segment, to get the whole mirror collimated so that it's perfectly in focus. Up in the right side here, you can see that there's an enormous difference between the warm side of the telescope and the cold side. Now, this telescope is set up so that there's a giant heat shield that separates the warm side from the cold side there, and it maintains that direction to keep the instrument package and the actual telescope itself cold as they can get it. So as far as they can determine, the front side is going to average about 185 Fahrenheit and the far side minus 388 Fahrenheit. So a difference approaching 500, 600 degrees, right? Fahrenheit is enormous temperature gradient over just a few layers of mylar. It's just astounding. And the computer is kept on the warm side, which obviously is better than it getting frozen on the other side. And also anything else to do with propulsion and balancing the whole telescope and keeping it pointed in the right direction. All that's on the warm side so that it won't freeze. And anything that they need to keep super cold is on the other side. Here's the Earth down here. The sun is to the left. You can see where Hubble is orbiting out at 570 kilometers roughly. You can see how far away roughly the moon is. And Webb is way the heck out here, 1.5 million kilometers out at this position called L2, which is Lagrange point 2. Now, there are 5 Lagrange points. I'll get to that in a second. I actually almost skipped ahead a slide there. So if you go on the NASA website for James Webb, you've got some like enormous amounts of information, and there's a tab that says, where is Webb? And this is that page. And these parts in blue here and here, I added in for my own information, but the rest is what you see on the screen. So it's giving you the elapsed time since launch, the distance in miles from the Earth, how far it has to go to reach L2, and what percentage of the distance it's gone on that journey. With about 85%, it's here. And its current speed at 0.19 miles per second. It's actually, the mission is designed so that as it goes further out, it slows down and slows down so that by the time it gets to L2, it's just creeping along and basically comes to a halt due to gravity right at L2, which is a stable point in space. Oh, okay. Apparently I got rid of one of my slides that I didn't intend to. Anyways, these Lagrange points, there's 5 of them. There's one on the other side of the sun, directly opposite us. There's one ahead of the Earth, about 60 degrees in the orbit. There's one behind us, 60 degrees. And there's one on either side of the Earth. L2 is on the side away from the Earth and the sun. The first three Lagrange points, 1, 2, and 3, are not perfectly stable points in space, where in order to keep a instrument package, satellite, or a telescope sitting there, you have to use propellant to hold it in position. But the amount of propellant is really, really small, and you can run for years on a very small amount of propellant and keep it at L2. So if you're interested in finding out more about Lagrange points, there's lots of information online. I had a slide in this presentation, but my presentation was way too long, so I took a few out. That was one I didn't mean to take out, so I apologize for that. Now, how about something fun to look at? It's cold outside. You may not want to spend a lot of time outside, but here's something that I've never looked at before, but I think is going to be an easy star hop for most beginners, and will also be a bit of fun. So unfortunately, this, I don't know if you can see this screen sharing little icons up here, but this little cluster here is known as the 37 cluster, the LE cluster, the little Pleiades, the shopping cart. It's got lots of names. Its proper names is NGC 2169 or Colander 83. It's a bright little cluster. It's not super impressive on its own, but it is fun to look at, which is why I'm going to look at it. So here's Orion. Everybody, I think, can find Orion. You go to Betelgeuse, the big orangey red supergiant here, and you head out along its arm to its club. And you've got nice bright stars to guide you here compared to all the stars in the area. This one's very bright. Takes you out to these two here. And then you can draw a little equilateral triangle to there. It's about a 1 degree on each side. And that's where 2169 is, the 37 cluster. So just put your crosshairs right about there between the two stars, and it should be in your field of view. And here's what it looks like, a nice image taken by this Joe Gafford on cloudy nights. And here you can actually see the 3 and the 7. Awesome. Now, if you turn that upside down, you get an L and an E. And then if you're really, 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 I think this is what they mean by the shopping cart. I think this is the handle, this is the cart, and this is the wheels over here. At least that's my guess, because I can't really see it. But when you look through the eyepiece, medium magnification, you should definitely be able to see that 37 or that LE, depending on the orientation of your telescope, mirrors, and lenses. Okay, so just going to talk about the actual sky this month. I was going to do more, but my talk went way too long, so I've cut it back a bit. But if you go out at about 8:30, this is for tomorrow, and the moon's going to be almost full. So really, tomorrow's not the best time, or the next couple of days. You should really, if you're going to start doing some star hopping and stuff, might want to wait a few days until after the moon is past full, so that it's rising a bit later. But still, this map is good for at least a few weeks. So around 8:30, you can go out, and this is facing east-southeast, and you should be able to see most of the winter sky. So what we have here is, of course, Orion, which is the first constellation that really people might want to learn as beginners. And if you're going to star hop, or you're going to use the stars as guides to get you to other stars in the sky, you can use Orion as pointer stars to get you to different spots in the sky. And some of the beginner books are very good at doing that. It's the same thing as you can do with the Big Dipper in the summer. You can certainly use Orion in the winter. And there's lots of really bright stars in the winter sky. So you've got lots of easy to find stars that will help you get started into new constellations as you learn them. So the stars that I'm talking about, if I start down here, you've got Sirius, which is the dog star in Canis Major. You can go to Rigel, you go to Betelgeuse. Up here is Aldebaran. I'll show you that in a minute. Castor and Pollux in Gemini. Procyon. It brings you sort of around in a great big loop and back to Sirius. You can use whatever works for you, but these bright stars are going to point you at a whole bunch of the winter constellations and give you a starting point for each one. One of the constellations that doesn't get a lot of viewing visually, in my opinion, is Lepus, which is down here. It's the rabbit. It's right below the base of Orion, and the part of it that you should be able to see is this box right here. Very badly mangled box. Anyways, that part you can see, and then you'll pick up these other stars over here. It never gets really high in the sky, but it's fun to be able to see the stuff that's near the horizon, see if you can pick it out. What else do you want to know? So in Gemini up here, here's the heads of the twins, and their feet are down here. And what's really nice is if you go from Castor all the way down to his toes, you're going to find a beautiful cluster there. And if you look at Castor itself, it's a beautiful double star system. But actually, if you were able to get a lot closer than we can, or a bigger view than we can with our scopes, you'd find out that each of those 2 stars has 2 more stars. It's a 6-star system. That'd be awesome to see, but they're very, very faint, far away. What's also interesting is that you've got a couple of the spring constellations already coming up over the horizon. So Cancer and Leo down here. Now, Cancer is very difficult to see. I've talked about that a few times over the years, but M44 right here, and I think it's 67 or 69 down here. These are 2 open clusters. M44 is a big one. It's really nice. Otherwise, I think called the Beehive. 67 is a bit smaller. It's down here. They're hard to find if you can't see any of the stars in Cancer, but you can give yourself a break. So you can find Pollux up here, and you can find Regulus and Leo down here. So you have to wait for Regulus to be up in the sky where you can see it. Draw an imaginary line, divide it by 2, and then run your binoculars around like this, and you will come across M44 no problem. So that is something really worth looking at. And even in a small telescope, it's a very pretty cluster to look at. Monoceros here in the middle is another one of these very, very dim constellations, which really you'll have no hope of seeing very much of in the city or even in a small town. But there is, if you can get your way from, say, the belt stars here, you can come down somewhere in this area right here is Monoceros B, and that's a triple star system, or at least visually there's 3 stars together there, 2 relatively bright, 1 much dimmer, but it's a really nice little object to look at. And really, if you're looking at these things from the city or from a town, and especially when you're starting out, you want to look for things that are bright and big, or at least really bright. So double star, triple star systems, those are bright. Open clusters are bright. Globulars are really nice, although the winter sky doesn't have very many of them. Certainly the Orion Nebula here is an awesome target, right? You can't go wrong. Rigel's a beautiful double. There's all kinds of things to look at, but when you get your observing guide and you start looking, for January, there's all these things to look at. Don't pick really dim, tiny things. Try and pick things that you can either star hop to successfully because you've learned that part of the sky, or if you've got you've got a hope of seeing with light pollution. Really, faint nebula, faint galaxies are a really tough chore in any kind of light pollution, but open clusters, multiple star systems, bright nebulae are all really good targets for this time of year. And of course, the winter Milky Way is coming up this way. So I'm looking in the same direction, but now I'm looking directly overhead. In Stellarium, that little Z, that's the zenith, so that's straight up. And here's Gemini down here, and now we're just looking up above Gemini and Orion. And you run into Taurus the bull with Aldebaran, the angry red eye of the bull. And you run into Auriga here, which has some really nice stuff in it. Even with binoculars, Auriga is just fantastic to look at. There's so much going on. And if you've got a telescope of any size, you can look at the 3 open clusters here, M38, 36, and 37. They're almost in a row. So with binoculars, certainly if you can find M38 roughly in the middle there, you can actually go down and catch the other 2, no problem. Above that, you've got Perseus, which is in the Milky Way. This area in here has got a fantastic, huge field of stars there. And you've got Algol, the demon star. And that is the star that every 2.8 days, roughly, it dims by about 3 times. It gets 3 times dimmer for a period of just maybe 8 to 10 hours. And then it comes right back and it's back to its normal self again. And you can get the information for Algol online in the monthly magazines. You can get it in your RASC handbook. The only thing I would suggest is check the times. I've noticed consistently that the RASC handbook and say Sky and Telescope times are off by hours and hours, like 5-6 hours for the minima. So I would err on the side of the earlier time rather than the later time. And then eventually we should be able to figure out, someone can figure out which of those 2 time sets is correct over a period of months. But Algol, when it gets dim, is really cool to look at. It's much more in terms of brightness, like the next star in the constellation here. It's about that bright. And it's really a very noticeable difference. So you can certainly spend a ton of time between Cassiopeia, Perseus, Auriga, Taurus, Gemini, Betelgeuse, Canis Major. You can spend nights and nights looking at just stuff that's there. And there's tons of stuff that is visible in small scopes. The sky is relatively easy to navigate when you're learning the constellations. And so for star hopping and pointing your telescope, it actually works out really well to try and find some of these really cool things to look at. And that's the end. Thank you very much.
Well, thank you, Matthew. That's great. Oh, where'd everybody go? There we are.
I actually lasted better than I thought. I've had a terrible cough for the last few weeks, and it's like asthma, and it's just been really bad today, but whatever, got away with it.
At one point there, I was going to jump in and give you and chatter for a minute to give you a chance to get a drink of water.
Well, I've got drinks of water and cough drops and all kinds of stuff. Turns out I'm allergic to Christmas trees. Wouldn't you know?
Okay, well, that begs a bunch of questions, but we'll just let that go.
Yep. Yeah.
Okay, anybody have any questions for Matthew on tonight's Sky This Month? Just speak up, please. No? Okay, good enough. Let's see. Our next meeting, well, first of all, I'd like to thank anybody and everybody that's participated tonight. Dr. Delaney for sure, Matthew, Melissa, and who else was in there? Sue for her great assistance, and I know I'm going to forget somebody, so throw rocks at me later. Those that are interested in the solar spots coming around, the sunspots, be sure to check out the Stereo A, which means ahead, Stereo Ahead satellite images. It'll show you what's coming around the side. Let's see, what else is there? Our next meeting will be on Friday, February the 11th. Mark her down. And that's it for me. Oh, just don't forget, anybody that's interested in contributing a couple of minutes to next month's meeting, let me know, please. Okay, that's it for me, folks. I was going to say drive safe, but nobody should be driving anywhere. But Yes, with winter upon us, do drive safe, please. We want to see you back again. And if you do go out tonight or anytime this winter, bear in mind that it's going to be very, very cold. And it's saying -20, so just for -30.
Oh.
Okay. Anyway, that's it.
Wow.
Talk amongst yourselves if you wish.
Good night, all.
Thank you. Good night.
Thank you very much. Thank you.
Bernie.
You're very welcome. My pleasure.
Thanks to all the new people who came tonight. It was great to see you all, and there's lots of positive comments in the chat.
Good stuff. Okay, I should actually read some of that stuff.
Good night, everyone.
Is there any way of keeping this?
Night.
Good night now.
Thanks, Bernie.